Okay, so good morning once again, everyone. So our last topic for this semester about operating system is about distributed processing, client server, and cluster. So in this lesson, we covered the server computing in client, service-oriented architecture, distributed message passing, remote procedure calls, clusters, Windows clusters, server, Beewolf, and Linux clusters. So as Winston Churchill, stated that the reader who has preserved thus far in this account will realize the difficulties that were coped with. So the hazards that were encountered, the mistakes that were made, and the work that was done. So the intended learning outcomes of this lesson should be that the student should be able to present a summary of the key aspect of client-server computing, define service-oriented architecture, understand the principal design issues for distributed message passing and remote procedural calls, clusters, and describe the cluster mechanism in Windows and Beowulf. So in this lesson, of course, we begin with an examination of some of the key concepts in distributed software, including client-server architecture, message passing, and remote procedure calls. Then we examine the increasingly important cluster architecture. The concept of client-server computing and related concept has become increasingly important in information technology systems. So in this topic begins with a description of the general nature of client-server computing, and this followed by a discussion of alternative ways of organizing the client-server functions. The issue of file cache consistency raised by use of file servers is then examined. And finally, this topic introduces the concept of middleware. Okay, so again, as with other new waves in the computer field, client-server computing comes with its own set of jargon words. Okay, so we have, of course, the application programming interfaces, the API. We have the client, middleware, relational database, server, structured query language, and so on. So to give us more details about the topic, let us all welcome Mr. Ryan Lor. Go ahead.
Distributed processing client, server, and cluster. Client machine, single user PCs or workstation that provide a highly user-friendly interface to the end user. The server provides a set of shared user services to the clients. The server enables many clients to access shared resources and large database. The server typically runs on a cloud or a high-performance computer system. Client-server application. Basic software is an operating system running on the hardware platforms. Platforms and the operating system of client and server may differ. These lower-level differences are irrelevant as long as client and server share the same communications, protocols, and support to the same application. Client-server application. Actual functions performed by the applications can be split up between client and server. Optimize platform and network resources. Optimize the ability of user to perform various tasks. Optimize the ability to cooperate with one another using shared resources. Database application. The server is a database server. Interaction between client and server is a form of transactions. The client makes a database request and receives a database response. Server is responsible for maintaining the database. This is the client architecture of the database application. Classes of client, server application, host, base processing not through client, server commuting traditional mainframe environment. Classes of client, server application, server-based processing. Server does all the processing. User of workstation provides a graphical user interface. Classes of client, server application, client-based processing. All application processing done at the client. Data validation routines and other database logic function are done at the server. Cooperative processing. Application processing is performed in optimized fashion, complex to the setup and maintain. Three-tier client, server application, architecture. Application software distributed among three types of machines: user machines, and client. Middle tier server, gateway, convert, protocols, merge, integrate, result from different data resources. Backend server, backend server. This is a three-tier client server application architecture. File cache of consistency. File caches holds recently accessed file records. Caches are consistent when they contain exact copies for remote data. File locking prevents simultaneous access to a file. This is a distributed file caching is sprite. Middleware. Set of tools that provides a uniform means and the style of access to system resources across all platforms. Enable programmers to build applications that look and feel the same. Enable programming to use the same method to access data. This is the role middleware in client. Logical view of middleware. Example of middleware functionality. Distributed message passing. Message pass used to communicate among processes. Send and receive message as used in a single system OR. Remote procedure calls. This is a basic message or processing primitives. Reliability versus unreliability. Reliable message passing guarantees a deliver if possible. Not necessary to let the sending process know that the message was delivered. Send the message out into communication network without reporting success or failure. Reduce complexity and overhead. Blocking versus non-blocking. Non-blocking, processing is suspended as a result of suing as send or receive, efficient and flexible, difficult to debug. And blocking, send does not return control to the sending process until the message has been transmitted. OR does not return control until the acknowledgement is received. Receive does not return until a message has been placed in the allocate buffer. Remote procedure calls allow program or different machines to interact using simple procedure call. return semantics, widely accept, standards, client server modules can be moved among computers and operating system easily. This is a remote procedure call mechanism. Client server binding. Binding specifies the relationship between remote procedure and calling program. Non-persistent binding. Logical connection established during remote procedure call. Persistent binding. Connection is sustained after the procedure returns. Synchronous versus asynchronous. Synchronous RPC behaves much like a subroutine call. Asynchronous RPC does not block the caller, enable a client to invoke a server repeatedly so that it has a number of requests in pipeline at one time. This is the objective-oriented machine middleware mechanism. Clusters. Alternative to symmetric multiprocessing. Group of interconnected whole computer working together as unified computing resource. Illusion is one machine. System can run on its own. Benefits of cluster. Of absolute scalability, incremental scalability. Can have dozens of machine, each of which is multiprocessor incremental scalability. Add the new system in small increment. High availability. Failure of one node does not mean loss of service. Superior price performance. Cluster can be equal to greater computing power than single large machine at a much lower cost. Cluster. Separate server. Each computer is separate server. No shared disk, need management or scheduling software. Data must be constantly copied among systems so each is current. Cluster. Shared nothing. Reduce communication overhead. Several servers connected to common disk. Disk partitioned into volumes. Each volume owned by a computer. If computer, another computer gets ownership of the volume. Shared disk, multiple computers share the same disk at the same time. Each computer has access to all of the volumes on all the disks. Operating system design issues. Failure management. Highly available cluster offers a high probability that all resources will be in service. No warranty about the state of partially executed transaction if failure occurs. Fault tolerant cluster. Ensure that all resources are always available. Load balancing. When a new computer added to the cluster, the load balancing facility should automatically include this computer in the scheduling application. Parallelizing computation, parallelizing compiler, parallelize application, parametric computing. Cluster middleware services and functions. Single entry point, single file hierarchy, single control point, single virtual networking, single memory space, single job management system. Cluster computer architecture, cluster middleware service and function. Single user interface, single I/O space, single process space, checkpointing, process migration. SMP is easier to make to manage the configure. SMP takes less space and draws less power. Clusters are better of incremental and absolute scalability. Clusters are superior in terms of availability. Windows 2000. Cluster service. Collection of software on each node that manage all cluster specific activity. Resource. Item managed by cluster service. Online. Online at node when providing service on the specific node. Group. Collection of resources managed a single unit. This is a window 2K cluster service blocking diagram. Sun cluster. Major components, object and communication support. Process management. Networking, global distributed file system. This is the Sun cluster and Sun cluster file system extension. Verilog and Linux cluster. Key features. Mass market commodity components. Dedicate processors rather than scavenging cycles from idle workstation. A dedicated private network, LAN or WAN, or interneted combination. No custom components. Easy replication from multiple vendors. Key features. Scalable IOA, freely available software base. Using freely available distribution computing tools with minimal changes. Returning the design and improvement to the community. Ilamang po, sir. So okay na po.
Okay, so again, the client server computing is the key to realizing the potential of information system and networks to improve productivity significantly in organizations. So with client server computing, applications are distributed to users on single user workstation and personal computers. So at the same time, resources that can and should be shared are maintained on server systems that are available to all clients. No? The client-server architecture is a blend of decentralized and decentralized computing. Typically, the client-server provides a graphical user interface, that enable a user to exploit a variety of applications with minimal training and relative ease. No? The server support shared utilities such as database management system. So the actual application is divided between client and server in a way intended to optimize ease of use and performance. The key mechanism required in a distributed system is inter-process communication. So two techniques are in common use. So a message passing facility generalizes the use of messages within a single system, and the same sort of conventions and synchronization rules apply. So another approach is the use of remote procedure call, no, or call. This is technique by which two programs on different machines interact using procedure call return syntax and semantics. Both the called and calling program behave as if the partner program were running on the same machine. On the other hand, a cluster is a group of interconnected whole computers working together as unified computing resource that can create the illusion of being one machine. And the term whole computer means a system that can run on its own apart from the cluster. So that's it for this topic.